Good morning, everybody. We're going to go ahead and start. This is the December WastewaterSCAN partner call, with the intended audience being all of the wastewater treatment plants and public health partners currently participating in WastewaterSCAN. Thank you, everybody. We wanted to sort of give a year-end wrap-up here. 2025 has been a great year for WastewaterSCAN. We have analyzed over 22,000 samples, and we've added 5 pathogens to the program through digital PCR. And we keep track of the views to the data dashboard, and there have been over 680,000 views of the data dashboard. So thank you all for your partnership over the last year. We always show this slide describing who we are, and despite this, there tends to be still a lot of confusion, but WastewaterSCAN is a project that's based at Stanford University. And we have a national network of sites, and we use consistent methods for monitoring diseases through the wastewater treatment plants and help inform public health response. Marlene Wolf at Emory and I are the 2 program directors, and you all are our partners. And then Verily is our contracted lab for logistics, lab analysis, and data and measurements made in-house. So just a quick overview. We have 147 plants serving 37 million people in 40 states participating in WastewaterSCAN. We monitor all of these different pathogens listed here using sensitive and specific digital PCR assays, as well as controls, PMMOV and bovine coronavirus, and we sequence SARS-CoV-2 using amplicon sequencing from 34 sites. The most recently added virus here is West Nile virus. All of our methods and protocols are available to you. You can scan these QR codes at a later time to access all of the methods and data. And I wanted to point out 2 recently published papers. One is on wastewater concentrations of rotavirus RNA and vaccination metrics in the US, and another is on the importance of a heat snap in quantification of rotavirus double-stranded RNA. And I'll go through sorry, as you can tell, I have a slight cough. I'll go over some of these results today. And then we have 2 preprints. One is about a national analysis of enterovirus D68, which we might share with you at the next stakeholder call, some of the results. And then we also have a preprint on our measles RNA detection in wastewater solids. And if you'd like to look at all of the publications coming out of WastewaterSCAN, because we are an academic project after all, you can click on this link later and see all of the peer-reviewed papers. We have a large number of fact sheets and information to help guide interpretation of the wastewater data. This is on the website, and so we encourage you and your colleagues and leadership to look here when there's questions, but we also are happy to take those questions from you. And oftentimes we can point you to documents here that have the answers. And then we also have a monthly newsletter, which is sent out monthly, and it's at ghost.io, which is a blog site. Okay, so wanted to give you all a measles update. So there are 25 sites across, I'm having trouble seeing the complete slide here. There are 25 WastewaterSCAN sites that have had at least 1 positive detection since we began prospective monitoring for measles in May 2025. So the sites that have had at least 1 detection are shown in red here on this plot, and then the state it's in is in gray. So you can see that we've had detections at a number of sites here. Oh yeah, I do want to point out that there are other efforts to monitor measles, and that information is not shown here. This is just WastewaterSCAN. And this shows the histogram of the types of concentrations that we're seeing in wastewater. So remember, we look in the wastewater solids, not in the liquid phase. So our units are copies per gram. And so this plot shows the number of positive samples that have been in each concentration bin shown on the x-axis here. So for example, we have two measurements that were over 50,000 copies per gram, which is quite high, the highest samples that we've measured concentrations. And then there are 35 samples where the samples are clearly above the detection limit, but they're less than 5,000 copies per gram. So our detection limit is about 1,000 copies per gram. In December, so right now it's December 12th. We've only had 2 positive measles detections, and those have both been in Utah at the same site in fairly consecutive samples. And then overall, we've had 67 positive detections out of over 13,000 samples analyzed. And each time we get a positive measles detection, we reach out to you, the plant and the public health, right away to let you know in advance. And we will be working to continue to do that over the holidays, despite a lot of people being out of the office. So we plan to try to continue that through the holidays. For more information on the methods and how we're interpreting measles concentrations, you can look at these websites, which they will be live in the PDF file that we send out after this call. And again, sorry that I'm coughing so much. Okay, so I wanted to just cover briefly the results from a paper that we published on heat snap for detecting rotavirus. As stated here, rotavirus is a double-stranded RNA virus, and it's the only double-stranded RNA virus that we work with in WastewaterSCAN. And there are not very many double-stranded RNA viruses that are considered in human health. There are a handful, but rotavirus is the only one. And as you might or might not remember or know, but in PCR, the target is typically double-stranded DNA if you're doing PCR. And part of the PCR process is an initial rise in temperature of the reaction, which causes the double-stranded DNA to denature into 2 single strands. And then the primers anneal and amplification occurs. So it's well understood that if you have a double-stranded nucleic acid, that you need to heat it to denature it to then give the enzymes access to do things. When we work with single-stranded RNA, which is a really common target in environmental virology, because there are so many single-stranded RNA viruses, we don't really have to we don't have to deal with that. So the typical RT-PCR reaction just starts out with the reverse transcription step, where it reverse transcribes RNA to DNA, and there's no initial heating of that reaction to denature any potential double-stranded molecules, because it's just not relevant. So we actually looked in the literature at a bunch of papers that measured rotavirus, and we found really inconsistent reporting of whether people were doing the so-called heat snap, which is initially heating up the RT-PCR reaction to denature the double-stranded RNA before the RT step. Some people reported doing it, some people didn't mention it at all. And so we thought, well, let's test this with our wastewater samples and see how important it is. So this project was a collaboration actually with a former student of mine who is a tenured researcher at EAVOG, which is a research institution in Switzerland. And so what we did is we took 38 wastewater solid samples from the United States, and these are samples from WastewaterSCAN, and we measured targets in those samples with and without a heat snap, not a heat SMAP. So we measured rotavirus, which is the double-stranded RNA virus, as well as parvovirus, which is single-stranded DNA, and adenovirus, which is double-stranded DNA. And basically the heat snap was heating the reaction to 99 degrees, followed by cooling before the RT step. And then we also took samples from wastewater treatment plants and drainage ditches in Uganda, and these are liquid samples. And we measured double-stranded RNA and single-stranded RNA with and without a heat snap. And this time the heat snap was similar, except it was just the template that was heated and not the entire reaction. We use digital droplet PCR for both the solids and the liquids, but for the solids, we use the Biorad system, and for the liquids, the Stilla system, which was actually purchased by Biorad recently. And we would expect if the heat snap doesn't matter, that the results with and without the heat snap would be the same. And so the results are here. So on the y-axis is the results of samples measured with a heat snap. So the units are copies per gram or copies per mil. And then on the x-axis is the concentration without a heat snap in the same units. And each color represents a different virus. And this line is the one-to-one line. So on this one-to-one line, if something falls on that line, it means that the heat snap didn't matter. So we see parvovirus, the single-stranded DNA, doesn't matter if you have a heat snap or not. Double-stranded DNA here in green, doesn't matter if you have a heat snap. And then this is norovirus, which is a single-stranded RNA virus, also on the one-to-one line, doesn't need a heat snap. But if you look at these guys up here, these are all the rotavirus measurements. They do not fall in the one-to-one line. And interestingly, they all seem to fall on the same line, even though they are different types of samples measured on different digital droplet instruments with different methods for isolating the nucleic acids, et cetera. And so these are the liquid samples, and here are the solid samples. And what we found is that the heat snap measures a higher concentration by a factor of 125 for the double-stranded RNA target. So we should be running a heat snap, but we don't, but we know that it's off by a factor of about 125. So that's the summary of that research project. You can access the paper in this slideshow if you want to read more about it. So ongoing research that we're doing is we're working on finishing up a study looking at pertussis and tuberculosis in wastewater. We have been working with a couple wastewater scan partners on this project, and if you know it, if you are working with us on that, and we'll share results with you all soon on that. We're also working on Ora-Puche virus, which we're also partnering with some of our WastewaterSCAN colleagues on that. And then we've been putting a lot of effort into developing scalable methods for viral metagenomics. As you guys have heard about, we have a phase A, B, and potentially phase C, and the phase A sites were selected and notified in October, and we continue to work on that. So with that, I'm going to pass it to Amanda to talk about the wastewater category updates.
Thank you, Allie. So I just want to give a caveat that these wastewater categories are with data through December 12th. So if you go to the website right now, that's what you will see at 9 a.m. on December 12th Pacific time. So next slide. So I want to give a high-level summary of where we're at. So I rearranged this slide so we could fit a lot more information in it. So right now we have SARS-CoV-2 in the high category, and that is due to an upward trend in median concentrations. I'm going to go into this in a little bit more detail in subsequent slides. Influenza A at the national level is in the low category, but it has hit seasonal onset in the Northeast, and it's about to hit seasonal onset in the South. Influenza B is in the low category due to not being in seasonal onset. Same with RSV, but concentrations are continuing to rise. Human metapneumovirus is in the low category as well. We've had a 31% positivity rate over the last 21 days for human metapneumovirus, so we're slowly starting to see an increase in concentrations and detections. EVD 68 nationally is in the low category, but has hit seasonal onset in the West, and I will share about that in a later slide. Neurovirus is in the high category due to an upward trend in median concentrations. C. auris, Hep A, measles, and Mpox clade 2 are in the low category due to limited detections. As Ali mentioned, with measles, we've had 2 detections since the beginning of December at a site in Utah. So that is why it's in that low category. And then Mpox clade 1b and West Nile virus are in the non-detect category because we have not had any positive detections in the last 21 days. Next slide. So here is the summary plot of the last 24 months. On the y-axis, you have all the respiratory pathogens we monitor that we have a longer time series for. They each have their own individual scales, so please note that. The orange line is where we were a year ago compared to today. So if you go all the way over to the right, that's where we are right now. And just a quick visual comparison, you can see we're a bit lower for influenza A, for RSV, than where we were a year ago. And I will show some other plots to clarify this a little bit more. Next slide. So as I mentioned, SARS-CoV-2 nationally is in the high category due to an upward trend in median concentrations. And this is mainly being driven by sites in the Northeast and the Midwest. As you can see, we've had an increase in both of those regions since mid-November, and they've gone up a bit more after the holidays. Interesting to note that these 2 regions are the coldest regions right now out of all the regions we monitor in. So I'll be curious to see how this pattern continues through the rest of the winter. So far in December, SARS-CoV-2 concentrations are up 21% compared to November, and we've had an 84% detection rate in December so far. So we have had some sites that are non-detect, but most sites are continuing to have positive detections, even if they are on the lower concentration end of the spectrum. Next slide. Here is the current wastewater category map for the sites in the WastewaterSCAN network. So as I mentioned, the Northeast and the Midwest are in that high category, so in that orange color. The South is slowly starting to tick up, and it has hit the threshold for medium. And then the West is in low, as most sites are in the low category. Next slide. This is a plot we've showed the last couple of stakeholder meetings. So this is looking at the percent of positive samples over every week. And so each individual line is the different respiratory pathogens we monitor. So if you look all the way over to the right, you can see we've had a pretty big increase in positive detections for influenza A, which is this purple line, and for RSV since November. They've almost grown exponentially. And so right now there's a 11% detection rate for influenza B, which is the green line, the lowest line on this plot. And then RSV is, let's see, almost 50%. Influenza A is around 70%, and human metapneumovirus is 31%. So we're continuing to see increases here. And EVD 68, forgot about that. That's in there as well. So I'm going to go over that in subsequent slides. Next. So influenza A, as I mentioned nationally, it is not in seasonal onset yet, but it has hit that threshold in the Northeast. So currently, if we look at all the 4 regions we monitor in, 37% of sites in the Midwest have hit the threshold for onset. In the Northeast, 78% of sites have hit the threshold for onset. In the South, about 50% of sites. So it's teetering on being an onset at the regional level. And then in the West, 46% of sites have hit the threshold for seasonal onset. In the last 21 days, 72% of all the samples we've measured have tested positive for influenza A. So as I mentioned, we're starting to see a pretty big increase in positive detections. We've had a 260% increase in concentrations in December compared to November. And if you look at the plots on the right, you can see we've got this tail end where concentrations are starting to tick up, and that is mirroring what is being measured in the positivity rates with the data we pulled from the CDC here. Next slide. So I wanted to introduce this new plot. So this is the last four respiratory virus seasons. So on the x-axis, it goes from week 40, so that's about the beginning of August, all the way through the next year. And each line represents a different season. So right now we're in the 2025 to 2026 season, and that's this red line. The dark blue line is last year, so 2024 to 2025. But as you can see across these last 3 years, we've had a slower start to influenza A season than we've had in the past. Where we're going to go, whether we're going to have as big of a peak as we did last year or a peak that's more similar to the 2022, 2023 season, we're not sure, but we will continue to incorporate this plot in subsequent stakeholder meetings in January and February to kind of give you a perspective of where we've been in the past versus where we are now. Next slide. Respiratory virus, RSV, as I mentioned, we haven't hit the threshold for onset yet, but we are starting to see a lot more positive detections in the last 21 days. We've had a 50% detection rate, and we've seen concentrations slowly increase since right around the Thanksgiving holiday, which is what is mirrored in both of the national aggregate line on the left and then in the positivity rate on the right. Next slide. And similar plot, but for RSV. So this current year is in 2025, 2026, and that's the red line. As you can see, we've had a slower start, similar to what we saw with influenza A. But last year, we saw a pretty significant increase early November. So we're a bit behind compared to what we saw these past 3 years. But concentrations may start to increase as we move through respiratory virus season. Next slide. EBD 68, as I mentioned, we are not in seasonal onset at the national level, but in the West, we have hit that threshold. So we have 24 sites that are in seasonal onset. And so at the tail end of this plot, this is showing the last 24 months of EBD 68 data. You can see we had a bit of a spike in the Midwest at the tail end of summer and into fall. And now we're seeing concentrations increase in the West, which is the blue line here. Next slide. Neurovirus. I'm sure plenty of you guys have seen neurovirus is all over the news right now. There's so many articles about neurovirus and the stomach bug. And we're seeing that in the wastewater data. We're in the high category due to an upward trend in median concentrations, 100% detection rate in the last 21 days, and concentrations are up 45% this month compared to November. Next slide. Here's a similar plot. I'm only looking at the last 3 years of data because that is what we have for neurovirus. So once again, this year is in the dark red. Last year is in dark blue. As you can see, 2024 to 2025 compared to 2023 to 2024, there was a lot of neurovirus that was clearly circulating last year compared to the previous year. So right now, our pattern looks kind of similar to the start of the 2023-2024 season. We didn't have as significant of an increase as we did compared to last year. But as always, we will continue to monitor and alert you as we move through the rest of sixth season. Next slide. Here's the current category map. So the West, the Northeast, and the South are all in the high category, and the Midwest is in the medium category currently for neurovirus. Next slide. So that is all that we have. But as always, if you have any questions, please email this listserv here. This goes to Allie, Marlene, myself, and Stephen, and one of us will get back to you as quick as we can. Next slide. Oh, I had a couple more slides, Allie.
Sorry. I will share. Sorry. I was too oh, it's gonna take me a minute, Amanda. Is it, are
Okay.
they really
I can just
important?
I want to say we're going to continue the Skating the Sewers events in 2026. And so we have a couple of topics lined up for February. We're going to do EVD 68. And so we're working on speakers and getting some items together for that. And then in March, we are hoping to cover CORIS. So we're working on getting speakers for that. And we would love to hear from you what other topics you'd like to hear from. So I just put a link in the chat with the form. So if you could fill that out, that would be great. As a reminder, these events are not recorded, and we will be sending out summaries of all of the 2025 events we've had shortly. But please fill out the survey if there's a certain topic you want us to cover, whether it be pathogen specific or whether it be a methodological specific topic or a communication specific topic. We'd love to hear from you so that we can make these sessions um, meet the needs that you guys have as our partners. Next slide. I think I mentioned this last time. We are having a respiratory virus season social campaign. So if you follow us on Instagram, LinkedIn, Facebook, all the platforms that we're on, we're starting to share out information on respiratory virus season and the different pathogens that we look at and where we are at throughout the season so that the public is informed as well. We have a toolkit for this, which I'll be linking in the summary email that I send out later. Like I said, it's partition. I cannot speak right now. Participation is voluntary. We have these assets available if you decide you want to use them for your departments or for your own personal use. So I will be sending out this information later. And I think that's the last slide. So thank you all. As Ali mentioned, thank you for a great year. We've done a lot of really amazing work together, and we're looking forward to 2026. Our next stakeholder call will be on January 9th, 2026, and we will be sending out the December newsletter at the beginning of January, since I will be off the last week of the year. And with that, we can take any questions.